All right, this next topic, last section of chapter 3, I totally forgot about this one, is dealing with solving equations and inequalities with absolute values. So we're saying, well, first off, we know absolute values, what they do is the x inside there can be positive or negative, some number. And it always comes out positive. So if I had absolute value of 3, the answer is 3. If I had absolute value of -3, the answer is 3. The absolute value, negative absolute value of -3 is -3. Because basically the absolute value is the distance any number is from 0. So the number 3 is 3 units away from 0. So is the number -3. It's also 3 units. So that's what the absolute value does. It takes whatever direction we have, positive or negative, and makes it into a positive. So the rule is this. Absolute value of x equals some number. Once you isolate the absolute value, whatever it equals, when you drop the absolute values, you have to put a plus or minus in front of the answer. So that's the formula, that's the rule. Example 1. The absolute value of x is equal to 5. Solve for x. Drop the absolute value sign. And that's my answer. X equals 5 and x equals -5. What if we had an equation? We have to isolate the absolute value. Same way we did with the radicals. Add 1 to both sides in this case. So absolute value of 3, x minus 3 is equal to 5. Now, since it's isolated, I could drop the absolute value sign. I have to put a plus or minus in front of the answer. Which means now I have to take this equation and set it equal to both of those. So I have x minus 3 is equal to positive 5. X minus 3 is equal to -5. So I add 3 to both sides. So x is equal to 8 and x is equal to -2. And if we check our answer, we get absolute value of 8 minus 3 minus 1. 8 minus 3 is 5. Absolute value of 5 is 5, minus 1 is 4. Then when x is equal to -2, we got -2 minus 3 minus 1, absolute value of -3 minus 2 equals 4. Negative 2 minus 3 is negative 5. So the absolute value of negative 5 minus 1. Absolute value of negative 5 is 5. Minus 1 is 4. So 4 equals 4. So our answers are both x equals 8 and negative 2. All right, so that's with absolute values. Equations. There's the equal something. Now let's look at inequalities with absolute values. Remember what I said, absolute values are distances from 0. So we can say that absolute value of x is less than some number, or absolute value of x is greater than some number. Let's look at this graphically. Here's 0. Here's some number a, and there's some number negative a. If x is less than a, in other words, it goes from a, it starts from a and goes down to 0. It's going towards 0. So it does the same thing from negative. It goes from a towards 0. They go in the same direction. So what this one says is, these are my x's. So my x's are between negative a and a. That's if it's a less than. If it's got a greater equal to, then I put equal to. Now, if x is greater than a, if x is greater than a, that means it's to the right. It's going to infinity. That means on the other side, it has to go to the left. It has to go to negative infinity. So if I have absolute value of x greater than a, then what this means is x is less than negative a, or x is greater than positive a. So those are our rules. So let's look at these examples. Absolute value of x is less than 3. So what that says, here's 0, there's 3, everything's less than 3. That means it's greater than, so that means it's going to be negative 3 is less than x is less than 3. Absolute value of x is greater than or equal to 1. So there's 1. It's greater than or equal to. So x's go to the right. That means from the negative 1, it has to go the opposite direction. So x is less than or equal to negative 1, or x is, here's x's, greater than equal to positive 1. Because there's an equal sign. It's solid. 2x plus 3 is less than equal to positive 4. So it's less than. So we know that negative 4, whatever's inside here, is going to be less than equal to positive 4. Subtract 3. We got -7 less than equal to 2x less than equal to +1. Divide by 2. So -7/2 is less than equal to x is less than equal to 1/2. Okay. This before. What about negatives? We can't do the absolute value sign until we get everything gone. So we have to change the signs. The absolute value of x, everything's got to change. That negative changes to positive. This one changes to greater than, and that one changes to -3. All right. So now when I look at this, we have a -3. So x is greater than -3, which means it's going this way. Negative of a -3. So you see, this is not working. So basically what it says is absolute value signs cannot equal a negative number. So absolute value of x cannot be less than some negative number. Right, so that's very, 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 very careful. So this is example 3. Three x plus 2 is less than 5. Remember, our rule said if it's less than, then it becomes. So this is isolated, so it becomes -5, 3x plus 2, 5. So it's whatever's inside there goes inside that, in the middle. Subtract 2, -7 is less than 3x is less than 3. Divide by 3. So -7/3, x and 1. What if the x inside the absolute value is negative? Whereas what if we had absolute value of -x is less than a? So if I drop the absolute value sign, this goes in the middle. When I change the sign, I change everything across the board. So this one goes from negative to a positive. That one goes from less than to greater than. That one goes from negative to positive, less than to greater than, and from positive to negative. So whenever you change a sign of X, you have to change everything, not only the signs of the numbers, but the directions of the inequalities. Example 4. So it dropped the absolute, since there's nothing left to do on this left side with absolute values. So we drop the absolute values because it's greater than, remember, if it's greater than, it has to go greater than the positive and less than the negative. So we have 5 minus 2x is less than equal to positive 1. That's the negative 1. Or 5 minus 2x is greater than positive 1. Because we have a positive side and we have a negative side. Subtract 5 from both sides. Negative 2x is less than negative 6. Negative 5, 1 minus 5. Or negative 2x is greater than equal to negative 4. I got to change the sign. So it goes from 2x, from less than to greater than to positive, to greater than positive 6. Change that. Change that. And change that. So we have positive 2x less than equal to positive 4x. Divided by 2. So x is greater than equal to 3, or x is less than equal to 2. So it's greater than 3 or less than 2. That's what it looks like. All right, so that's that section. Sorry I missed it yesterday.